Okay, you guys ready? Here I go. I'm going to teach you today what's called integration by substitution. Okay? A couple things about this. Sometimes called U substitution because a lot of times we'll use the variable U when we do this. But I want you to understand what this really is. This is the chain rule backwards. It really is. So remember, we're doing antiderivatives, right? So the important rules, okay, are really the product rule, quotient rule. You can kind of use the product rule if you want, and the chain rule. So if you understand how the chain rule works, then you're in good shape. And I guess we just demonstrated that. Here. When I say integration by substitution is the chain rule backwards. How does the chain rule work? Well, chain rule says that if you're trying to find the derivative of, I don't know, f of g, let's use the Newton notation. If you're doing the derivative of a function, it says what you get is f prime of g of x, ding, times what? Times what? Yeah, you need the derivative of what's inside, right? G prime of x. Well, when we do antiderivatives, this kind of thing's going to come up. But one thing that I think will help us is differential notation, okay? So we will use differential notation when integrating. And I think you're going to find that that helps a lot. So, first example for today is going to be one that works out, well, really nice. I'd like to think of this problem. I'd like to integrate four x minus 5 squared times 4 dx. I'm going to start off with indefinite integrals, and then we'll move to definite again in a little bit. So right now, I just want the antiderivative. Okay. Can you get the antiderivative? And if I gave this to you now, some of you would say, hey, I can do that. I'll just square 4x minus 5. I'll get a trinomial. Then I'll distribute the 4. And then I'll get the right answer. And you would get the right answer. It would take you a couple of steps. You guys with me? But if I make that 2 into a 12, you're not going to be so happy anymore. Okay? So what I'd really like to do is I would love it if this were true. I would love it if the answer were 1/3 4x minus 5 cubed plus c. I wish that were the answer. Now, does that work? Well, how do you check if it works? Take the derivative. So let's check. Check and see if it works. Okay. So to check, I will take the derivative of, well, this mess. So the derivative of 1/3 4x minus 5 cubed plus c. I really don't need to write the plus c, right? What do I get? Bing. Bing. And then what? Bong. Did it work? It worked. I got what I started with, right? Because the 3's canceled, and I was left with what I started with. Now, there's something here that made this work out. The original problem, right? What was I very lucky was there in the original problem? This 4. It's almost like, what's that doing there? That was there to make it work out, right? If it weren't there, not so lucky anymore. Okay? Now, what would you do if you had been given the same problem without the 4? Well, now it won't work, right? I can't just integrate it the same way, because if I were to check my work, the 4 wouldn't be there, right? Here, you do the same thing. In other words, this is not the answer. Are you with me? So the idea is going to be this. If I have this problem, what I would like to do is change it so there's a 4 there. Well, I can do that if I also multiply by 1/4. Are you with me? I'm allowed to do that. And then what I'm going to do is I'm going to say, oh, when you take the derivative of a constant in front of a function, remember how you can just ignore the constant if you want to? Well, this is a constant that's kind of bothering me. So I'm going to ignore it and put it out front. And so I'm going to get this. You guys with me? And then what's going to happen is I already worked out the answer to this problem up above. The answer to this problem, we said, was 1/3 4x minus 5 cubed plus c. So if you ask me, hey, what's the integral of 4x minus 5 squared dx? I would say the answer is 1/12 times 4x minus 5 cubed plus c. And that's actually faster than go ahead and multiply it all out once you practice a few times. What's the tricky part? I think the tricky part is right at the beginning, knowing what to multiply by. I mean, why did I multiply by 4 and 1/4? Well, I'm going to try and show you kind of a technique today that could kind of help us through that. You guys follow? We're going to be making a substitution. I can't resist. I have to go here next. How many are familiar with this function? E. Thank you. How about the one on the left? You guys familiar with e to the negative x squared? Some would argue it's the most important function in mathematics. How many have never seen this function, they think? How many have seen it? Where have you seen it? Do you know? Go ahead. What is it? Do you know what it is or what it looks like or not remember? Liam says, I've seen that before. E to the negative x squared. We should sketch a graph. Okay? Well, when you plug in 0, what do you get? 1. E to anything to the 0 power is 1. So this function goes right through 0, 1. This function is an even function, which means the graph is going to have symmetry with which axis? The y-axis. And this function also has an asymptote, a horizontal asymptote. What happens when x goes to infinity? E to the negative x squared. Do you know? I'm trying to graph y equals e to the negative x squared. When x gets really big, e to the negative x squared gets really Small, really close to what number? 0. This has an asymptote here. It turns out, like I said, I said this is one of the most important functions in mathematics. This is a graph of what's usually called the bell curve. That's your, right? That's your equation of the bell curve, basically. And in statistics, for instance, what you do is you compute probabilities based on the bell curve. And what the probabilities are areas between this, say, this value and that value. You say, hey, what's the probability that my daughter's SAT score is going to be between, or ACT score is going to be between 20 and 30? And that will represent, if 22 is an average or something, I don't know, that will be represented by an area. And if you can compute that area, you would have the probability. You guys with me? So it would be nice to be able to integrate the one on the problem on the left here, e to the negative x squared. Unfortunately, this is one of those problems that you can't do in Calc 1, you can't do in Calc 2, and I can't do either. Nobody can do it. Why bring it up, Paul? Well, it's an important integral. So actually, how many have taken a stats class? Let me ask that. How many will take a stats class? Actually, a lot more of you than you think. You'd be surprised. When you take stats and you have to find this area, you know what they do? They give you an approximation. The calculator does it. How? With a bunch of rectangles. Okay? So we can't get the exact value, but we get an approximate value, and that's good enough. Now, the one on the right, that one I can do. Again, because this extra stuff, this negative 2x, that's kind of like having the 4. So that's the one we're going to do. All right? Let's see if we can integrate negative 2x e to the negative x squared dx. And I want to show it to you using integration by substitution. Oh, I forgot. We haven't covered the function e to the x yet at all. You guys don't know the derivative of e to the x? Yeah, some of you do. You learned it before from another calc class. But most of us didn't. That's what makes it such a cool function. Matter of fact, time out here for a minute. In order to do this problem, we need to know a fact. Fact. The derivative of e to the x is e to the x. That's a fact you guys need. All right. Once I have a new derivative formula, and by the way, you'll learn this in Chapter 7, but we're cheating. Once you have that, give me an antiderivative. What's the antiderivative of e to the x? What a great, isn't this a great example?
Can that just be our entire test?
Yeah, I think so. Well, how about this one? But it's funny because that one's so easy, and I said you can't take the antiderivative of e to the negative x squared, and that's the one I want to take. But I can do this one, and let me show you how. I'm going to make a substitution. This is our first time doing it, so I'm going to go slow. Here I go. I'm going to let u represent negative x squared. Because what I want to write is I want to write e to the u. Are you with me? Because I have a fact that's about e to the variable. Okay? Next, I take the derivative. And by the way, I'm going to write something down that most people don't write down here. I'll write it down at first. What is du dx? Everybody agree? Okay. Usually I don't write that. Usually what I do is I write that equation in differential form. We did that in Chapter 4, Section 5. we'll write it this way. du, that differential, is equal to, what will I say? Negative 2x dx. Does that make sense to you guys? That's the differential form of the blue. That's okay? All right. So I'm trying to rewrite the integral. And so I claim that we can rewrite the integral as e to the u du. Integral e to the u du. Why did I say we can do that? The real thing to check here is, do I have du? Well, I do, because du is negative 2x dx. Notice, well, if I show you here and here, do you see it? You need to account for everything. We have e to the u, and then everything else gives me du. Okay, see that? Now, what's the antiderivative of e to the u du? E to the u plus c, right? That was the fact that I used. And now, the final answer, I want x's, I don't want u's anymore. So what's my final answer going to be? E to the, we've got to go back to what we started with. U equals negative x squared. So negative x squared plus c. There it is. That's an example of integration by substitution. And this is the process that I think takes time to master. So I assigned a lot of homework. And I don't expect it's all going to be done Friday, but I know you're going to attempt. And then Friday we're going to come in and do a group work. And we'll continue working on it. And I'd say by next Monday or so you're going to feel more comfortable. Mike?
Well, if we can do that when we have e to the negative x squared, why can't we do that when we just have e to the negative x squared?
That's a great question. Let's try it. What would happen if I did that? Integrate e to the negative x squared dx. Okay, so what's your suggestion? Same thing, right? Let u equal negative x squared, right? Okay, what does du equal? Well, we did that before. It's negative 2x dx, correct? Okay, my problem is, when I go to write it, I get e to the u, but I can't write du. I just have, the only thing I have up there is dx. I don't have this stuff. And see,
so you need the derivative of your u in the integral in order to be able to go backwards.
that's right. I need the differential to match the variable.
Oh, okay.
And u is some function of x, so it doesn't work out. And by the way, what you're really doing here is you're doing the chain rule backwards. If you look at the last example we had with the 4, I didn't show you the substitution. Maybe I should. I mean, we kind of just threw it in there. Here, let's do it one more time. Let's do it using my new technique of substitution. So I'm trying to integrate 4x minus 5 squared dx. Okay? And a lot of times the whole trick is, what should I let u equal? And I'll tell you a good answer. Let u equal whatever's in parentheses. Because that's your inner function of the chain rule. So it's like this. I'm going to say, hey, let u equal 4x minus 5. Is that okay? So then I would write du equals, what's the derivative of 4x minus 5? 4 dx. I don't write du dx. I just write du equals 4 dx. Raise your hand if you're with me up to this point. I just want to make sure. That's not bad. Okay, so now what? Well, now we rewrite the integral. How do we rewrite it? Oh, I can't quite rewrite it yet because I don't have 4 dx. You see that? So, I mean, I have the 4x minus 5. That's cool. But what I really want is I want 4 dx. So what do? I showed you this. To get the 4 dx, I'm also going to multiply by what? 1/4. And that's what I did when I did the problem. Remember that 1/4? And so I get 1/4 integral. This is now u squared. And now I do have the du. But if you didn't multiply by the 1/4, you wouldn't have the du. Guys following? Next step. 1/4 times 1/3 u cubed plus c. And you can see I'm going to get 1/12. The u is my 4x minus 5 cubed plus c, exactly like I did last time. That's how you would do it with a u substitution, it's called. And now I feel like you guys just need practice and you need examples. And so for the last half hour, I'm going to fire problems at you and we're going to try and do them with the substitution method. All right? So here I go. Let's do these two next. Here's 2 problems you can work on. Because some of you are ahead of other people. But let's write them both down. Let's work them out. Try and get u, try and get du, and we'll go at it. All right. That first one, e to the x over square. You know, this is really a chapter 7 problem because you guys don't know what the derivative of e to the x is, do you? Oh, well, I guess you do. All right. And then the other one, antiderivative of x squared, square root of x cubed plus 9 dx. Okay. So let's see. For the first one, what do I want to do? I think we should, for the first one, any idea what you want to let u equal? It's a good guess, but no. I'm not going to let u equal e to the x. I'm going to let it equal 1 plus e to the x. That's right. Now, how do you know? I don't know. How'd you guess, Nick? Sometimes you don't know. Okay. Yeah, it's in parentheses next to the square root. And you know what's going to happen, guys? You're going to be working on the homework. You'll try e to the x. You'll put it in for u. And if you do that, your thing would say u over square root of 1 plus u, and you wouldn't have du. And you'd say, oh, it didn't work. Then you try something else. Do you see that? If I let u, let me demonstrate that. I hate to show people the wrong way to do it, though. But if I let u equal e to the x, this would say u over square root of 1 plus u. But I would still have dx here. I wouldn't have du. You need to get du. So let me write this out carefully. Okay, we're going to let u equal e to the x. Then what does du actually equal? E to the x dx. Now wait a minute. I just told you that's not what to do. All right, we'll try it again. We said let's take Nick's advice and do u equal 1 plus e to the x. That's better. Now what's the derivative? What's du? It's still e to the x dx. And that's beautiful because I'm going to have it now. Here, if you look at what I have, that e to the x dx is sitting here. See that? So watch what we get now. We're going to write this as antiderivative of, well, that whole mess is my du. I could either put it there or I could put a 1 and put the du out. I've shown you guys that, right? You can put it either place. And then I have the square root of u. Guys with me? Another way to write this, I guess, is 1 over the square root of u du. I don't know which way you're more comfortable with. They're the same. Okay. Did that help? Is this something I can integrate? At least there's no e's. How would I want to rewrite it again if I want to integrate it? That's right. U to the negative 1/2 du. Now I can integrate it, right? So let me work this out carefully. I'm going to get u to the positive 1/2, right? And then what number would I have to put out front? Got to put a 2 out front, plus c. Not done. Almost done. What's the final thing to do? Yeah, plug this value back in for u, which is 1 plus e to the x. So my final answer would be 2. And instead of writing 1/2 power, I think I'll write square root 1 plus e to the x plus c. There it is. Can you check your work? How can you check your work here? Take the derivative. Let me try it. Derivative of 2, 1 plus e to the x to the 1/2 power. I'll forget about the plus c. That's 2 times 1/2 times 1 plus e to the x to the minus 1/2. So that's bing, bing, bong. What's bong? E to the x. See, that's the chain rule. Again, the substitution allows me to do the chain rule backwards. And sure enough, if you write what that equals, you'll get what we started with. That's what we started with inside the integral. Okay, see? You have to be tenacious. You have to be relentless. Never quit. You're going to try substituting something in for u, it doesn't work. Here, let's try the next one. X squared times the square root of x cubed plus 9. Any idea what I might let u equal? Shout it out.
X cubed plus 9.
So one person said x squared, one person said x cubed plus 9. More people say x cubed plus 9. I'll go with the majority rule here. All right. Next step. After you compute u, the next step is to compute what? Du. Matt, what does du equal? Not 1/2. Let me see. It was x cubed plus 9 was my u. So what's the derivative? Almost. You forgot Bing. Bing. You did Bing. You need Bing and Bing. I put them on the spot. That wasn't nice. Then again, I'm always on the spot. All right, 3x squared, right? Well, not just 3x squared. What else should I write? 3x squared dx. There it is. Do I have the du? Not quite. What's the only thing I need? I need a 3. Can I get it? Yes, I can. So I'm going to say that this is equal to what? Well, to get the 3 in there, I will also multiply the outside by 1/3. So I'm going to say this is 1/3 the integral of what? Well, do you see that this is going to be the square root of u du? Does that make sense to you guys? Because the du is all this stuff right here that I just put in the box. 3x squared dx. You guys follow? All right, try to finish up this problem, and then I'll kind of see where we go next. All right, let me help finish up. We have 1/3 integral u to the 1/2 du. I'll catch up to you guys quickly. 1/3. Now this becomes u to the 3/2 power, so you put a 2/3 out front, plus c. And so my answer to this second problem would be 2/9, some stuff to the 3/2 power plus c. And what's the stuff? The stuff was x cubed plus 9. There's my answer. Oh, here's my answer. Okay? All right, let's go back, try the next two. Here they are. I need a new sheet of paper. Sine of 3x plus 4 dx. We're going to integrate that. And then we're going to integrate this other one. Wow, okay. So let's see. Antiderivative of sine of 3x plus 4. What I'd like you to do for the first one is write down what u equals and write down what du equals, and then check with someone next to you before you continue. Okay? And we'll see if you guys agree on this or not. So let's see, we have the u here would be 3x plus 4. Du is 3 dx. So now, oh, I don't have that, do I? So what do I need? We need a 1/3. So we're going to say that this blue integral here equals 1/3 the integral sine of u du. We okay with that? Okay. What's the antiderivative of sine? Negative cosine. So I get 1/3 times negative cosine of u plus c. And so the final answer for the first one would be negative 1/3 cosine of 3x plus 4 plus c. Okay? It's almost like what the substitution does is it takes you through the chain rule and you figure out what to put in front to make it all work when if you were to check your work. Go ahead, take the derivative of that. You'll get back sine of 3x plus 4. All right, the other one. The other one is kind of like the example I did with e to the negative x squared. The only reason it works is because there's an x here. Here, watch how this goes. Let u equal what? X squared. Now du is equal to 2x dx. Okay? Now I don't have 2x dx. I have 3x dx, right? Let me show you how I would work this out. I guess what I would do is this. I would say that this equals 3 times the integral of x cosine of x squared dx. But I really want to get a 2 in there. So then it equals 3/2 integral of 2x cosine of x squared dx. That way I get the du in there. Okay? So I get 3/2 integral cosine of u du. You have to get the du in there. And now let's see what we have. We have, what's the antiderivative of cosine? Okay. So the answer, I guess, would be 3/2 sine of x squared plus c. By the way, this just reminds me of another problem that nobody can do. It's been proven no one can integrate this one. You can't. You could try. Then you get du equals, well, 2x dx, right? I've had people ask me, well, can't you just multiply by like 1 over 2x and put the 2x on the inside? And the answer is no. You can't put a variable past the integral sign. Only a constant can go in and out of the integral sign. Because an antiderivative of a constant, the constant doesn't affect the derivative. Okay? So yeah, this one can't do. But if you need to compute a definite integral, to find an area, for instance, you could use left sum and right sum. That works. You get an approximate value. Okay. Next, 2 more. Good examples. Would you guys try these for a little bit? And we'll see where you go. All right, I got about 10 minutes. No, 15 minutes. That's enough to do a little bit here. All right, here we go. For the first one, you guys let u equal 3 theta. You let du equal what? 3 d theta. Do I have 3 d theta? No. I don't have 3 d theta, so what do I multiply by? 1/3. How many think that they got the first problem? All right, can I show you something else? Matt mentioned this, and I usually call this the Armstrong approach because Bill Armstrong is one of our faculty here that teaches calculus, and he likes to show his students this right away. I show you what I show you, but I want to show you another method. And it's to take one more step. And so it's this. You write d theta, and you just say what that equals. In other words, I solve for it. How? Divide both sides by 3, right? So you get du over 3, which is 1/3 du. And so if you go this approach, you'll realize that, oh, okay, where it used to say d theta, I can replace that with 1/3 du. And this then is the integral of secant squared u. And now you pull the 1/3 out front. I don't care if you guys like that approach better. I'm okay with it. My only issue is make sure that you've changed variables completely. You don't have x's and u's in the same integral. Okay, what's the antiderivative of secant squared? What is it? Tangent. Yeah, the derivative of tangent is secant squared. So that knowing those derivatives is essential, or else we're not going to get any farther. So there it is, 1/3 tangent of u plus c, and we said u was 3 theta, so I think the final answer would be 1/3 tangent of 3 theta plus c. All right. Now, the second one. Did anybody make any progress that they were happy with on this one? How many tried this one? Oh, you need more time then. All right. Let me pause for a minute and talk to each other about what you might let u equal. Remember that if you think you have something, you should compute du, and it ought to be sitting there also. So talk to each other about that for the next minute. You know, the only advice I gave about selecting u is take what's in parentheses. Now, you don't see any parentheses, but there are some there, kind of. What's kind of in parentheses? The sine of x, right? When we say sine squared of x, remember what that means. It really means, right, sine of x squared is what that really means, right, guys? So I'm going to do this. I'm going to let u equal the sine of x in a way that's in parentheses. Now, is it the only way to work? I don't know. We'll see. Du. What does du equal if I do that? Cosine x dx. Okay. Now let's see what we have then. Well, I would have 4, and then what would I have next? Well, that's u squared. You guys see that? And then this piece right here, what's left, is du. And I think it's interesting to note that you can use this u substitution in a lot of ways. Over here, I let u equal the part inside the trig function. And over here, I actually let it equal the trig function. And some of those problems I said you can't integrate yet, you got to wait till Calc 2. You're going to do a substitution in Calc 2 called an inverse trigonometric substitution, where you use this inverse trig function crazy substitution, and it works. But we wait on that until Calc 2. You can get very creative with substitutions at times and suddenly solve problems that you never could have solved before. So anyways, let me do this antiderivative. I get, well, 4 times 1/3 u cubed plus c. And so my final answer would be 4/3. How would I write u cubed? I'd write it as sine cubed of x plus c. That's okay? Good. Now it's funny because I've been doing all these antiderivatives using substitution, but I haven't yet shown you a definite integral. So I kind of want to end the class doing a couple of definite integrals. Let's try this one first. So here I go. I'll integrate from 0 to 3 x squared square root of x cubed plus 9 dx. I picked this one because I have a feeling you'll know exactly what to let u equal and what to let du equal. Actually, did we already do this one? Yeah. That's why I picked it. We did it already. Wait a minute. What did we let u equal? X third plus 9. And then we let du equal 3x squared dx, correct? And so you get 1/3, well, it's integral of u to the 1/2 du. We did this already. Oh, time out a second. There's something I didn't write down here. And I want to warn you that if you write down 0 and 3, you're liable to get into trouble. Because 0 and 3 are what kind of values? Oh, you can't see. Yeah. You're like, huh? 0 and 3 are what kind of values? X values. Right? Aren't they values of x? They're not u values. I mean, I understand that if I'm finding the area under the curve, whatever the curve looks like, I'm basically going from x equals 0 to x equals 3. I understand that. But u is some, like, foreign world. So there's a couple ways to handle this. One way to handle this is to remember that you just wrote u is a function of x. u of x equals x cubed plus 9. So, for example, when x is 0, I can work out that u equals what? 9. And so where it used to say 0 here, I can put a 9. Is this okay? What about where it used to say 3? $36. Those are nice numbers. You'll see. So I'm going to take the definite integral from 9 to 36. All right, let's see what happens. I get 1/3 times, and then this becomes u to the 3/2, and it becomes 2/3. And I'm going from 9 to 36. But that's the key difference. When you have a definite integral, you might want to change the x values to u values so you can plug them in. Let's see what I get. 2/9, and this would be 36 to the 3/2 power minus 2/9 of 9 to the 3/2 power. That's the fundamental theorem of calculus. Does that make sense to people? Yep, Mike?
Are you doing any harm if we just not change the values and just go until we get back to x and then plug it in?
That is the other way to proceed, okay? You guys understand what Mike's saying? Mike's saying he doesn't want to do this. Mike's saying he wants to do this. He wants to write, instead of that step, he wants to write 1/3 integral u to the 1/2 du. He wants to leave it as x equals 0, x equals 3. If you do that, Mike, please put an x or something. So you don't.
I'm worried that if I start plunking in different values, I would confuse myself.
Well, right. That's why I'm always real deliberate about it. I say, I'll do this. Like if I'm doing what you're doing. So I get 1/3 times 2/3 u to the 3/2. But over here I'll say x equals 0, x equals 3, so I don't plug them in by accident. And now what Mike would get is he would get 2/9. And what did u equal? Oh, it was x cubed plus 9. And now you're good. You can go from 0 to 3. Of course, if you plug them in, look what you're going to get. 2/9 of 3 cubed plus 9. Do you guys know what that is? What's 3 cubed plus 9? Yeah, you're going to get 2/9 of 36 to the 3/2 power. This is all the 3/2 power. You're going to get the same thing. Either way, this is what you get. And Mike, it's funny you say that, because when I first learned definite integration, I did what you're saying. I always switched back to x and then plugged in, even though it takes a little longer in a way. I just felt more comfortable for a while doing that. But it's helpful to know both methods. It's helpful to know both methods. Either way, I should probably finish this problem. Let's see. So, how do you take 36 to the 3/2 power? Well, take the root first. Square root, right? So this is 2/9. Here, I'll factor out the 2/9. What I have is 6 cubed minus, and then the square root of 9 is 3, 3 cubed. So I get 2/9 of 216 minus 9. No, minus 27. So I get 2/9. This blue has almost served its course, guys. So what do I get? 189? Is that right? Who cares? Done. Okay. At this point, calculator. You guys with me? Is the last problem worth doing? That's our question. Oh, yeah. That's... Well, maybe we'll set it up and we'll start class with it next time, just with a setup. Here we go. Because I don't think I'm going to finish that entire integral in. Of course, the nice thing about a definite integral, I could do it on my calculator, right? And get an approximate answer. 30 minus x squared squared dx. Okay, so this crazy thing, what do you think I would let u equal? That's what I would do. So let's see how this works. U is equal to 30 minus x squared. Du is equal to what? Negative 2x dx. Wait a minute, I don't have dx's both places. What did I copy down wrong? I do have dx's both places. That was stupid. You won't see that in the book or it's a typo. Right? It's one or the other. Here, get rid of that one. Okay. Do I have negative 2x dx? No. What do I multiply by? Negative 1/2. So this equals negative 1/2. Then I get the du where I wanted it. Integral du over u squared. But as I said, we would have to take care here and here. So if you plug in a 3, what's 30 minus 9 is 21. And if you plug in a 5, 30 minus 25 is 5. So one weird thing about this problem is that, see how the numbers can change? You can get the bottom one is bigger than the top. But it all works out in the end. We'll work on that next time, guys. That's how we'll start class, I think. All right? Hope you enjoyed. I'll see you on Friday.